keeping up with our motto, let learning be a joy and teaching a pleasure. Here we are with a remote teaching and learning process to bridge the gap. Happy learning, students.
Hello students. Today we are going to see the chapter from Science and Technology part 1. Chapter number 4, that is effects of electric current. In this topic we are going to see the subtopics as energy transfer in an electric circuit, what are the heating effects of electric current, magnetic effect of electric current, and right hand thumb rule. Students, before starting with the topic of electric current, let us understand what is electric current. Electric current is nothing but the flow of electrons in a circuit. That is, when the electrons flows in a circuit in a particular direction, we get electric current in the opposite direction. So the flow of electrons in a circuit is responsible for this electric current. Now, we know that metals are good conductors of electricity. It is because of these free electrons which are present in the metal, we say that these metals are a good conductor of electricity. Now, how the metal conducts electricity, or how this electricity is transferred through a metal? Let us understand how this electricity or how this energy is transferred through a metal. Here we have got an activity for this. The materials used in this electric circuit are, the first one is a battery or a DC power supply. The second picture is of variable DC supply. The third picture is alternating current voltage supply. The fourth picture is wire. Then again, coming from up on the right hand side, the first one is galvanometer, represented as G. Then we have got ammeter, which is represented as A. Then we have got voltmeter, which is represented as V. Then we have got resistor, which is represented with the zigzag line. And then we have got capacitor, which is represented by two parallel lines. These are certain basic symbols which are used in any electrical circuit. So before drawing an electric circuit, we should be aware of this electronic equipments or these symbols. Now, the procedure to make an electric circuit. Now, how we are making an electric circuit or how we form an electric circuit. First thing is connect the circuit as shown in the figure after taking the components of proper values. Then measure the current, that is I, potential difference, that is V, between the ends of A and B of the resistance, and the potential at A is considered higher than the potential at B, as the point A is connected to the positive electrode of the cell and the point B is connected to the negative electrode of the cell. Now, the procedure for that is, in this diagram, if you'll observe it, if a charge Q flows from A to B, work VQ has been done on Q while going from A to B. From where does this energy come to do this work? This source of energy is the cell. That is, the energy is supplied by the cell. And as we know that the energy or the electric current flows from higher energy level to the lower energy level, in this case the electric current starts from the positive end and it comes through A and then comes towards the B. That is the reason it is given while going from A to B. Here, if the charge Q flows from A to B in a time t, then the energy VQ is given to the resistor. So AB is the resistor, the energy is VQ. Now this energy is received by the resistor, and since the resistor gets the energy, it is getting converted into heat energy. Now the temperature of the resistors is increased since more electrons are moving. There is a collision between the electrons, and this collision between the electrons gives rise to the heat, and this opposition to the flow of electrons gives rise to a term called as resistance. So as the resistance increases, the temperature is also increased. Here, the relation between the heat and the energy is given as P equals to electrical power, that is energy, upon time required. It is the same definition which we have seen it earlier. Power is defined as the rate of doing work, that is work upon time. And work, as we have seen earlier, it is given by VQ, that is energy, VAB into Q upon T. Now Q upon T is equals to I. Because in the earlier class, 9th standard, we have done Q equals to I into T in Ohm's law. Now since Q equals to I into T, I is equals to Q upon T. So Q upon T is replaced by I. So we are getting VAB into I. Let this be equation number 1. Now H is equals to P into T. H is the amount of heat generated. That is nothing but the work done, is equals to power into time. And as we have got in the equation number 1, power is equals to VAB into I. So it becomes VAB into I into T. Let this be equation number 2. Now, according to the Ohm's law, V equals to I into R. That is VAB is equals to I into R. If I am substituting this value of VAB equals to I into R in equation number 2, we will get it H is equals to V square AB into T upon R. So what has happened here is VAB is equals to I into R, so I is equals to VAB upon R. And I is equals to VAB upon R. If I am substituting this, I will get H is equals to V square AB into T upon R. Similarly, by substituting the values, I can get H is equals to I square RT. This is called as Joule's law of heating. That means the amount of heat generated in a conductor because of passing of electric current is directly proportional to the current. It is directly proportional to the resistance of the conductor, and it is directly proportional to the time for which it passes. That means if I am passing more current, the substance will get more heated. If I am passing current for a longer time, the substance will get more heated. At the same time, if the resistance of the conductor is high, the substance will be getting more heated. This is called as Joule's law of heating. This heat was invented by the scientist called as James Watt. Here is a picture of James Watt. He was working in the era 1736 to 1819, and he developed the concept of a SI unit of power. So the unit of power is named as watt after him, that is James Watt. Now this heat which is generated because of passing of electric current can be utilized in different ways, which we call as heating effect of electric current. Means whenever current passes through the wire gets heated up that heat is utilized in different appliances. For example, electric bulb. Electric bulb consists of a thin tungsten filament at the center. Now this filament is made up of a thin metal. So when the current passes through the metal gets heated up and the light is emitted because of that heat. So that is called as heating effect of electric current. The next application of heating effect of electric current is electric iron. In electric iron, you can see one part which is labeled as element. This element is a metal coil which is made up of nichrome wire. That means this nichrome wire is a metal. So through the cord which is connected, the current enters into this element and the element becomes red hot. Now when this element becomes red hot, the heat is given out. This heat passes through the mica sheet which is placed below it. Now mica is a good conductor of heat but a bad conductor of electricity. That means it is allowing the heat to pass through it, but it is not allowing the electricity to pass through it. As a result, the heat passes through this mica sheet and the metal plate which is placed at the bottom of the electric iron gets heated up. And this heat is utilized to press the clothes. So that is called as heating effect of electric current. Many other appliances like electric oven, electric geyser are the appliances which works on the same concept of heating effect of electric current. The next is magnetic effect of electric current. So till now we have seen that when current passes through the wire gets heated up. Similarly, when a current passes through a wire, a magnetic field is formed surrounding the wire. Now that was observed by the scientist Hans Ørsted. As a scientist at the forefront, he has performed an important role in understanding electromagnetism. He observed that when a current passes through a metal wire, the magnetic needle near the wire turns through a certain angles. So we have got two diagrams over here. In the first diagram, when the current starts passing in one particular direction, that is from A to B, as soon as the current starts, the magnetic needle starts showing the deflection. But when the current was put off, the magnetic deflection stopped. So that indicates that the magnetic effect is produced only after passing electric current. Then he has reversed the direction of current. In the next diagram, we can see the current is flowing from B to A. As the current starts flowing from B to A, the magnetic needle again started deflecting but in the different angle. So thus he concludes that whenever current passes through a wire, a magnetic field is formed surrounding the wire. That is called as relation between electricity and magnetism. Today, advanced technology is developed as a consequence. In this honor, the unit of intensity of magnetic field is termed as Ørsted, after remembering the scientist Hans Ørsted. So that is about the magnetic effect of electric current. The same magnetic effect of electric current can be seen in this diagram. Here, a thin sheet is taken of cardboard and passing through this sheet at the center, a thick copper wire is there. And on that sheet, some magnetic needles are sprinkled. As the current passes through the wire, this magnetic needle starts forming the concentric circles surrounding the wire. Now, this magnetic needle starts forming the concentric circle that indicates that the magnetic field is formed surrounding the wire. Now, that can be clearly seen with the help of this particular activity. So, that indicates that whenever current passes through the wire, a magnetic field is formed surrounding the wire. So, that is about magnetic effect of electric current. The next part is about right hand thumb rule. Right hand thumb rule states that imagine a conductor to be held in your right hand with a thumb stretched in the outward direction. The thumb indicates the direction of current and the curved finger indicates the magnetic field. So here we got a relation between the electric current and magnetic field. That is, electric current is I and the magnetic field is B. So both of them are mutually perpendicular to each other. So this is the relation which is given in the right hand thumb rule. So we have seen the heating effect, magnetic effect and the right hand thumb rule in this part. The remaining part will be seen in the next class. This right hand thumb rule is also called as Maxwell corkscrew rule. So that's all from this part. Thank you, dear students.